Hey guys, now let us learn about the centrifugal clutch in detail. So now defining it, it works on the principle of centrifugal force exerted on a revolving mass which acts as a engaging force engaging force These clutches are widely used in machine tools and automobiles. So let us draw the diagram. This was the definitions. Let us draw the diagram. Now let us draw the diagram. Just make two circles concentric to each other. And after that, sorry for this, and after that make 4 rectangle bars or square identical shapes, and just double their boundaries. And add a spring inside each. And after that extend the outer part with a curve 1. Preferably use your scale. Drawing the rough diagram just. And a spider which holds these them together with the input shaft and this part is called as friction lining. Now let us have the nomenclature of them. This part is called as a friction lining. This part is called as a rim, which is the output, and the input is this part, also called as output, and this part is called as input. Friction lining, here it is called as a spider which holds all their mechanism. After that this part is called as a shoe the spring. Here the input shaft and the output. Here the power will be transmitted from input to output, and all these will go radially upwards. And the another diagram is a V shape with friction lining mounted and the rim part which is fixed. Now let the center of gravity be G. Let the distance be R, radius of from the center to that of the output be R, rim, and from center to this distance be a small r. Let the force be acted radially inward, and here the theta, and the other force, that is centrifugal force, will be here. It is the spring force acting inward, and the centrifugal force here will be acting outward, radially outward. So this was the diagram. Now let us see the construction of them. So what is the construction? This clutch consists of number of shoes 1, 2, 3, 4, whose outer surface are curved, so that the friction is provided between the rim and the outer surface of the shoe. These shoes, which can be moved radially outward, are held in the position by means of a spring. You can see it is holded by a spring which acts a radially outward force at the time of rotation. When this start rotating, this part will get exerted radially outward with the friction lining, which is controlled by the spring mechanism. Construction, that is spring holds on friction lining and spider holds on all the shoes. Here the friction lining is in a curved shape. Outer rim is there to have power transmitted. And after that there are also rim, shoe, spider, spring and all that. Now let us see how it works. When the driving shaft, that is here input, when the driving shaft revolves, it exerts a radially outward centrifugal force on the shoe, mass magnitude of which depends upon the speed of the shaft. Here, when the input shaft is rotated, the power is transmitted from the input shaft, and as soon as it starts rotating, the centrifugal force, as the speed reaches a certain limit, the centrifugal force gets acted upon the spring, which gets a radially outward direction, and as soon as it goes to the outward direction, the friction lining gets pressurized on the rim inner part. Here the rim inner part is also have some sort of friction lining, so that the power transmitted much more. So the centrifugal force on the shoe also increases. When the centrifugal force exceeds the spring resistance force, as soon as the power is transmitted to the input shaft, and it is transmitted to the centrifugal force is transmitted to the shoe block, and as soon as the centrifugal force exceeds the spring force, this part gets in contact with the inner surface of the rim. As soon as the inner surface of the rim gets in contact with the contact with the outer surface of the friction lining, it also starts rotating. So this was the working principle. Basically, the required magnitude is specified, and it should be in a limit to rotate the outer surface. So let us write it. Friction lining or shoe brake must overcome the spring force to have power transmission. Here therefore the clutch gets engaged to the inner surface, and the power is transmitted, or the torque is transmitted. The driver shaft gains sufficient speed to take the load efficiently. So the clutch gets engaged to inner surface of rim to transmit torque and power. So now let us derive the force exerted. Now let us derive the equation for friction torque transmitted by n number of shoes. N number of shoes. So let from the corresponding to this diagram, let M be mass of each shoes, M and G be center of gravity of shoe, small r be radius of distance between center of gravity and the center. Larger RB, radius of inside rim. Here omega b, speed of shaft. Omega eb, speed of shaft at time of engagement. And mu be the coefficient of friction between shoe and shoe and rim. So let the centrifugal force exerted on each shoe at time of engagement that is Fe equals to resistance applied by spring, that is force of spring. Here it is input force and output force. Input output FEFS. Now continuing, here it is the engagement force, can be written as mr omega e engagement square, omega e square. Now engagement force equals to spring force equals to mr omega e square. So let this be equation 1. And the centrifugal force on each shoe would be Fc, that is Fc equals to mr omega square. So let it be as second. And now the net force can be calculated as net force exerted by shoe on rim can be found out as net force equals to centrifugal force minus spring force. As we know that spring force equals to spring force, where it is here, that is mr omega engagement square, and this centrifugal force equals to, this would be mr omega square. Therefore this gets converted to, taking mr common, omega square minus omega e square. So we have got Fn. Now the frictional torque on each shoes can be calculated as, writing the formula, can be calculated as frictional torque equals to frictional force into radius r, where you can see frictional force is net force into mu and r as it is, where Fn equals to, you can see over here, Fn is mr omega square minus omega e the whole square and r as it is. Now putting all in, we get m mu r larger r omega square minus omega e square. So this is the frictional torque for one shoe. Now for n number of shoes, just multiply it, the whole equation, by n. That is Tf equals to n into the whole equation, m mu r omega square minus omega e the whole square. So this is the answer and the derived equation for the frictional torque for n number of shoes. Thank you guys for watching. Sorry, it is not the whole square, it is square, omega e square. Thanks guys for watching.